Can I have a quick question for the Samsung S Pen people? Could you tell me on Thursday during my office hours what you guys are planning to do? Because I saw your notice that you were changing your plans.
Kind of finalized it.
Okay. Can we talk about it on Thursday? Just come a few minutes before class to my office, and that'd be great. But if you have some documents, send it to me before, so then I can look at it. All right. So no quiz today, but there will be one on Thursday because today we cover lots of new stuff. Also, a reminder that homework 5 asks about your progress reports and so on. So just to make sure that you have that. And so today we're going to get going with iPhone programming. So, and as you'll realize as I go through this, I'm learning this 2 days faster than you do, but we'll get through it. So, as you probably know, to do development with iPhone, you must use a Mac. There's a development environment that's actually quite nice called Xcode that you get from the App Store. You can use any programming language you like as long as it is Objective-C. And so we're going to be having to learn this Objective-C thing. So in the 1980s, there was this language called Smalltalk that really was way, way ahead of its time. And so it wasn't really the first serious object-oriented programming language. And you could do all these very graphical things with it that no other environment could do. But it was kind of a niche because it was a huge monolithic system. So Smalltalk was itself written in Smalltalk, and so the people would take this development environment and they would morph it into something else by writing Smalltalk code. And when you were done with all that morphing, then you'd have to export your entire everything and run it on another computer. And so it wasn't really something that was easy to make standalone programs that someone could just run like on their PC. And they somehow had never really overcome that. It doesn't sound like something that should be impossible to do, but it was just not their thing. And so some people wanted then to take the good ideas from Smalltalk, the objects, and add them to C. And so they made this preprocessor that took a mixture of C and Smalltalk-like things, and they called it Objective-C because it added objects to C. And it went absolutely nowhere real fast. The other approach of adding objects to C was C++, and C++ got all the attention. And to remember those days, I had to look at Objective-C. I scratched my head, said, who needs it? I looked at C++, and I bought a ticket to the first C++ conference because this was clearly the wave of the future. And so it was, except with this, curiously enough, then this next step environment that was done by Steve Jobs after he got kicked out of Apple, in the early history of Apple, so he started this other company that built this thing, and they used a development environment that was based, of all things, in Objective-C. And so, and we'll see as we go through why this might have happened. And then, of course, Steve Jobs went back to Apple. Apple had fallen on hard times with their previous versions of the Mac OS, and then he introduced Mac OS 10 that was built on the same technology that they had at the next step, and Objective-C became the language to write any Mac applications. So if you wanted to write native Mac applications, you had to learn Objective-C, and so that wasn't that many people who did that, I don't think. But of course, when the iPhone came out, everyone out of a sudden had to learn Objective-C, and so do we. So here's my crash course on how one can quickly learn it. So So first of all, let's start with what we already well know. In method calls, you know that in Java and C++ and so on, you call a method like this. You have an object, dot method, and then you have the arguments inside. And you kind of think, how could it be any different? But in Smalltalk, it actually was very different. And in Smalltalk, you don't call a method, but you send a message. And so instead of calling this method, you would send a message, and you would say, what's the difference? What's Obj going to do when it gets that message? Well, of course, it's going to do the same thing as it would do in Java when you call the method. Except that's not actually quite true. Most of the time, it'll do the same thing, but if you wanted to do some extra special stuff, you could rig it so that a message does something other than just executes the lines in a method. So for example, you could make one object delegate all of the messages that it gets automatically to another object. You could write a generic delegator for that. That's tough to do in a language such as Java or C++ that's statically typed. But Smalltalk and Objective-C are dynamically typed in the object system. And so you get a certain degree of dynamism out of this. And I guess that's what makes it sometimes easier to do these kind of tricks that make for a fluid development environment. So, but for practical purposes, you probably don't really have to care. I think you can go quite a ways in Objective-C without ever having to worry that it's really different. The syntax, on the other hand, is totally different. And so that's the translation you need to make in your mind right away. That instead of calling obj.method, you enclose the whole thing in brackets. And so that's just a different way of kind of getting the same effect. And the other weirdness is that the method name is split up into different pieces. And so if you have n explicit arguments, then the method name has n pieces, and each of which ends in a colon, and then you interleave. This is the implicit argument, the receiver of the message, and then you have first part of the method name, first argument, second part of the method name, second argument. So I'll give you a better example in this abstract stuff. If you look down here, so my array is an object. Insert object colon obj says you want to insert an object into this array. Add index 1 means you want to insert it index 1. And it reads pretty nice, right? My object, insert this object, add index 1. And in this case, the name of the method is insert object colon add index colon. So they actually like to use these long descriptive method names, which makes the code easy to read. And I guess if you have autocompletion, then you don't worry about the fact that it takes a long time to type. So sometimes you hear that these things are like named parameters, but they're really not, and it's probably not that helpful to think about them. Just think of them that if you wanted to make a method in Objective-C, you would have to figure out how many parameters does that method have. You would have to come up with some name that has a colon and a gap per parameter, and that somehow makes a nice description. And then conversely, the caller, when they see a method like that, they see how many parameters it has by the colons, and then they stick them, one here and one here. So it's easy enough. It's just different, and what's better? They're perfectly equivalent, and we don't have a choice anyway. That's how they are. Now, the way that classes are defined are kind of like in C++. So if you've seen this in C++, you separate the interface of the class from the implementation, and you actually usually put the interface of the class, meaning just the name of the class and the names of the methods. You put those into one file, into a header file, and then you put the implementation into the source file. And that part is the same in Objective-C, and that really comes from the C heritage of both of them. So you put the interface into the header file with extension .h, that way it can get shared between all of the modules that need to use it. So here is the syntax. Anything that starts with an at is a keyword in Objective-C to distinguish it from the keywords in C. So I should say that, and you're not seeing that right now because right now everything that you see is strange. But a large part of Objective-C is simply C. Any C code is valid Objective-C code. And so they have to have a way of distinguishing, what's the add-on here. Between interface and end, you define your class. You put the instance variables in here, just kind of like you would do with a struct in C or with a class in C++ in the normal way. Use the colon for inheritance, just like you do in C++. But the way that you describe the methods is completely different. So first of all, they use these symbols here, plus and minus. Plus is a static method, and minus is an instant method. One just has to remember it. I have no idea where the plus and minus come from, but I guess they were just there on the keyboard waiting to be used. And it looks a little weird when you look at, because you usually have a lot of the minuses, right? You almost always have many more instance methods than static methods. So when you look at the code, you have all of these minus, 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 and it looks all very negative, but I guess after a while one just realizes, oh, that just means the instance methods. So and then the way that you define the instance methods is when you look at the name, so it is split up into these pieces, here, here, and it goes on here. So just like when you call it, each piece ends in a colon, and then you put the parameter types inside parentheses in here. And so you put the parentheses around every one of them, which looks a little odd. And then the return type you put in front also in parentheses. Yeah?
What's the difference between an instance method and a class method?
Oh, a class method is a static method. Just like in any other language, that a static method is not executed on objects. So like in C++, you would say math.square root is a static method. Yeah?
Is there a way to declare a public / private or private?
I don't think so. Does anyone?
No.
It's not, right? Yeah. And in fact, I don't even know whether there is a way of actually protecting the instance variables. I think anyone can access them, but I'm not totally sure. I'll find out. So this is a static method, and you call it on a class. And the exact same would be true. There is no math class in Objective-C, I'm sure. But let's say I'll make one up. For some reason, they all start with NS, and I don't know why. It's not Netscape. But if there was one, then you would call it on the class like that. The class would be the receiver. So that these are here the class methods, the class methods. And actually, the name class method makes a lot of sense, right? Because you invoke them on the class. Whereas in C++ and Java, why are they called static methods? Why are they called static methods? But why the word static? What makes them static? Like static cling, like in your dryer? So the trivia fact of the day, nothing to do with Objective-C, but just about C++ and Java. In C, static has a different meaning. What's static in C mean? Actually, it has two different meanings, but what is the...
It's only available in this file.
What's that?
It's only available in this file, this source file.
Okay, that's actually not the original meaning. The original meaning of static was that when you have a block, I'll describe it in here. And inside here, you say static in X, N. And you left the block, and then you came back, X was still around. That's the original meaning of static. And it's a rarely used feature. I mean, when do you need this? Then the second meaning of static was to make something private inside a compilation unit. That when you said static, it wasn't visible outside. That's the one that you were saying. And then when they needed a way of saying, okay, how are we going to distinguish instance methods from class methods? They said, well, we have this keyword static lying around that's not used for very many purposes. We'll just reuse that keyword because it's there. They could have equally well used while, and that would have saved them a letter. But so static makes absolutely no sense, and it's kind of crazy that 20 years later, 30 years later, in C++ and Java, we still use this one thing just because they didn't want to introduce a new keyword. They didn't want to have some other way of distinguishing class and instance methods. They might have known about the plus and minus and found them ridiculous, and so they just reused static. And C++ in particular was always very, very nervous about adding any new keywords, because adding a new keyword into an existing language means that some code might break that previously used that keyword as an identifier. And so I remember when Strostrup introduced exception handling with throw and catch, and everyone was unhappy about introducing two new keywords into an existing language. Because any code that used throw or catch as a variable name or as a function name would now break. And so Strostrup tried to convince a whole bunch of us that one could actually do both of them with the same keyword. You could tell from context whether it was throwing or catching. And then they would toss a coin to figure out which of the two it meant. And most people looked at it and said, this is really ugly. And I actually pointed out that you could use static unambiguously and not introduce any of the keywords, and then they introduced them both. So, fortunately. But so it's always something in these languages. That's also what gives you these weird symbols like the plus minus and the colon. Instead, in Java they started from scratch, they could use extends, and here you don't. So when you see some of these odd things, that's the underlying rationale. Okay, well now we've beaten this to death. So so the implementation is done in an M file. The M was chosen because it does not exist anywhere in the word Objective-C. So you have the add thing, the implementation here. Here then you define your methods. Again, here we define a method with a plus, that's a static method. Here we define a method with a minus. And that part is pretty straightforward. Notice that only the methods go in here, the instance variables are in the H file. So to construct objects, there's not really the feature of constructors like that we have in C++ or Java. Instead, you first allocate the memory, and you do that by sending the class, the alloc method, that's defined somewhere deep down in object, and that just allocates the naked memory of this. And then it's by convention you call a method called init that you then implement to fill the object. And now it says these are class methods, and I'm not totally sure that's true. I'm pretty sure that this one, I know this one is a class method, obviously. But now that I look at it, this to me looks like an instance method. And I'll double check that. And so then your job is to make init be like a default constructor. And then you can use other methods to populate your object with data. For all I know, you could give init some arguments, but then of course it would no longer be called init. And I don't actually know how that works. I've seen like plenty of other objects floating around where you have some other class method to construct instances. So you kind of have these factory methods. And that's a good way of doing it anyway. And constructors are overrated. properties. So in Java, you have these things where you have an instance variable, a getter, and a setter. And they occur so often that Eclipse can actually type the getter and setter for you. And so that's a very common idiom. That's, in JavaScript, you don't have to worry about it because you have direct field access. But in a language that takes that wants to give some privacy to the fields, you have that idiom. In C#, there's a way of automatically getting the getters and setters, and there have been efforts to put that into Java, but they've never gotten anywhere. So in Objective-C, it's similar, except the naming convention is slightly different. Instead of having get name, set name, it's just name and set name. And that's as good as anything. It's just slightly different. You can automatically generate the getters and setters in Objective-C with this @property advice. So @property generates the getters and setters for a field. So here we have the field. It's a field called name, and its type is a string. I'll talk about the pointer in just a minute. So right now, ignore this non-atomic and retain stuff. We'll get into that later. Just every time you have to type a property, you just type the whole thing. So this goes into the H file because it decorates an instance variable, and the instance variables go into the H file. In the M file, you now have to put this magic thing here so that it actually does synthesize the getter and setter. So you can kind of see the flavor of this, that you kind of have to put in little knobs here and there to make the right thing happen, and it becomes second nature pretty soon. Once you do that, you can use the dot notation. You can see q.name, and that way you can access the getter. And if you say q.name equals, then it calls the setter behind the scenes. Some people don't like the dot notation, but I mean, I think that's such a standard thing these days. So, so this is the same thing as yeah. It just looks like a more standard notation. So generally, in Objective-C, it seems to be that one makes a property out of just about everything. So we're not as concerned about encapsulation as we are in Java. In Java, one is reluctant to expose every field as a property, but I've looked at the Objective-C code that I've seen they don't seem to care. A few miscellaneous things. The null reference is written as nil in IL. That's progress. It saves a character. Strings are written, on the other hand, you have to put an ampersand, or no, an @ sign before the string. And the reason is that the strings without the @ sign are C strings. And with an @ sign, then they are Objective-C strings. They can handle Unicode and everything. And so they internally represented somehow different. I have no idea how. Just remember to put in the @ sign. I was told, and I haven't actually given this a try, that if you omit it by accident, then your program will compile and crash when it runs. Does anyone know whether that's true? Well, it's worth trying it out. Self is like this in Java. It's exactly the same thing. And in Smalltalk, it was called self. I have no idea why C++ and Java changed it to this. You have a bunch of library classes and a string. Again, I don't know what the NS is. Array, mutable array. So by default, an array is immutable, and a dictionary is like a hash table. And I've given you a link to the API reference where you can find these things. Now, it's important that you realize that everything that you manipulate that is an object, you have a pointer to the thing. Just like in Java, you have a reference to the thing. But you have to do that manually. So in Java, when you say, whatever, J button Fred equals, then as you know, that thing is a reference to some object. fields inside. And so it's a reference. You could have another reference to the same object simply by saying v2 equals Fred. And that's just how Java works, that a variable in Java holds, it really holds, of course, a pointer to the object, but we call it a reference. So in Objective-C, you have to explicitly put the star for the pointer, and so you just have to kind of get used to putting a star every time that you use one of these, any of these types. And that's just the way it is. I'm sure I could have figured out a better way of doing it, but they didn't ask me. So, so you have to put the star, and if you don't put the star, I don't actually have any idea what happens. I'd be interested in knowing. There's one exception. There is a type called ID that has been defined to be a pointer to an object, and with that you don't use the star. So if you say ID greeting, then that means it is a pointer. It's a pointer to some object. We don't know what that object is. This is exactly the equivalent of the object type in Java. So that's what these are. Now Apple then went into Objective-C, that had been kind of defined by some individual people. Objective-C is not like C++, where there's a standards committee and where there's a standard form of the language, or like Java, where the Java specification process and people try to hash out exactly what's the defined behavior of Java. Objective-C is much more like Visual Basic. That Microsoft took some basic, called it Visual Basic, and then modifies it whenever it sees fit. And the same thing is true for Objective-C. So Apple, without even changing the name, takes its implementation of Objective-C and adds a ton of Apple-only features that would not work like if you wanted to do Objective-C programming on some other platform. Not that many people do. So one of the things that they do is they put in these keywords. When the keyword starts with IB, then it directs the interface builder to do something. So here the interface builder does an outlet. We'll see in a minute what an outlet is. And there's another thing that you'll see today called IB action. These things don't do anything in Objective-C for the compilation, but they are markers for the interface builder so that these are special in some way. So they've added these things to make it kind of like add these language constructs to help the interface builder. So it's a little bit strange. In Java, one wouldn't do it that way. In Java, one might use what are they called? Annotations to do the same effect. There's no concept of annotations, so these are just added in an ad hoc way. Okay, so I asked Dr. Pollard which book he likes, and so the one that he likes is fortunately on Safari, so I've given you a link for that. And the chapters are very short, so chapter 12 to 16 sounds scary, but it's actually just a couple of pages a chapter. So read through those so that you get a bit more background information, and then that'll be in the quiz for Thursday. So for the lab, match yourself up with a buddy who has a Mac. And whose buddy? Who has no Mac buddy? You guys? Okay, you guys. That's it. Okay. Oh, you guys. So how many Macs? How many 2 Macs do we have? You have 2 Macs. Does anyone else have 2 Macs? So we'll have to break you guys up. Anyone else with 2 Macs? Then, but I think we'll be good because I brought my Mac. So. Then that'll work out. Okay, so let's get that organized. And then the lab is very, very simple. So just get through that. Okay, so you guys can use my Mac. Let's double check that. You'll just have to use the guest account. Yeah, and so on.
Jake. This will be by default. Output.
So have you done iOS development?
No.
No.
It will be there on that.
How do you do it?
I just need to update.
Let's see, you are the odd one out. There should be one more group with two Macs.
Well, there's offered by students.
Oh, I see.
Emulator.
You have a Mac emulator? Okay, I guess you should just join them then. I see a Mac, I wanna see your Mac emulator, I mean, I've never seen one of those.
Yeah.
Okay,
Okay. Yeah, you can see here and
Non-Mac,
how did you come here?
just describe to this, right away, either way. There's not much to write.
I downloaded a image from
Xcode is in English. And Safari, for some reason,
Make a new single view and create
So you say you have an emulator? Okay, how do you get it to the,
single view.
from somewhere?
Set the set the prefix to SJC.
So
Okay.
you might wanna,
Capital.
maybe what happens is
On the left, select the .xib file.
yeah,
Check only the second check.
go on.
Okay. Then give next, maybe you will get it. On left, select the .xib file.
It's because of the one is try to pick the project again. Is that opening?
Do I know?
That's in the middle.
Oh, you're on that anyway. So here's Xcode, and we can just go to the lab. You don't have to, get going and hack your way through. Yes? It's some file that specifies the layout. It's like the XML thing, like the layout XML file.
Oh, okay. So
But you're not yet at the point where you can see it, right? Oh, okay, so make your project.
here.
Yes, so that's good. Can you make it anyway? I have no idea. That would be nice. I think I just put it on the desktop, but the better way to put it is, can you put it in your workspace?
My workspace.
In that workspace that you use for checking and stuff.
There is something.
Oh, I see. It's not in your. Okay, then put it in the desktop.
Yeah.
I hadn't realized that. For next time, we'll figure out.
But I can do the report here, but they need password.
We'll do it. Now you should see the XML. Yes.
Thank you.
Yes.
You just created it?
It makes it get it writes it to
Let's click on the view.
It's like when you can control space and then
Click on the cube and search for label.
No, but you don't have to write
Select
that.
the option.
Yeah, so drag that.
Click on it and change it to hello.
Click on the cube.
Yeah, so that's all.
Yeah.
search for
Is
name.
that right? Right?
Yeah.
Click on that view.
Where do you get to see it? Oh. Is you running it as an iPad? You want to run it as an iPhone? What do we?
Click on search for label, drag the label on the center of the UI content. Okay, you will